Okay, so today we are looking at growth and decay day 2, and mainly we're going to look at compound interest and half-life. However, before we get there, I've got a little warm-up that I want you to do, looking exactly at what we did yesterday, deciding whether these are growth or decay, and then what the percentage is. So I'm going to give you about 4 minutes to get started right here, and then we'll go over those. Ready, set, go. All right, so let's check this. I gave you 4 minutes to work on it. So remember, going through and figuring out whether they are growth or decay is really going to be kind of easiest. This first one, it is above 1, so this is considered to be a growth. The one below it is below 1, so it is considered to be a decay. All right, those are the two easy ones. Now, down here on the bottom, what you need to do is take each of those fractions and make them into decimals. So if you go 7 divided by 6 in your calculator, you end up getting 1.16666 and forever 7. Just going to round it there. And then 2/3 becomes 0.6667. Okay? So you know all of that's going on there. All right, well, that means this top one would be another example of a growth. And then down here at the bottom, it would be a decay. All right, that's all the stuff that we learned yesterday. Now, how you figure out what the percentage is you got to take whatever is given to you. So in this case up top, it was 1.682. Subtract 1 from it. That decimal is the decimal to make your percentage. How you make it a percentage, y'all talked about it. You can either slide it 2 decimal places, or you can multiply it by 100. But for this first one, it would be 68.2%. For the next one, you end up with 0.089 minus 1, and you end up getting out negative 0.911. When you slide that one over, you end up getting 91.1%. Down here, same idea. You go 1.167. I'm just going to go ahead and reduce it down some. Minus 1. So you get out 0.167. Then if you slide that over, you get 16.7%. Same idea with the last one. 0.667 minus 1 ends up getting you negative 0.333, which ends up being 33.3%. Okay, so we saw a lot of that on our homework. We saw it yesterday in our notes, and we just got to do a little example of getting that stuff figured out. Okay, now the rest of today is a little bit of new stuff. We're going to spend it on half-life, and we're going to spend it on compound interest. All right, the first thing we're going to look at is half-life. Half-life is slightly different than anything you've seen. And you might be looking at this saying, well, wait a second, Coach Dasher. That looks exactly like a decay function. It's got an A, your initial amount. It's got 0.5 in there. And then it's got a T. Here's what's different. Half-life, you only need 2 things. You need your initial amount, which is your A value, which isn't any different. But the thing that is new is your T. In half-life, your T is not just the number of days. T is 2 different time periods combined into one. What a half-life is it's a scientific term that is generally used with elements, okay? And elements will last for a certain period of time before it dies off or goes away. Something like that. Some elements do that, okay? So like in this example down here, it's carbon-14. Well, carbon-14 will last, this say the half-life of it is 37 days. So that means after 37 days, however much you had, it was cut in half. And then after another 37 days, whatever was cut in half the first time is cut in half again. Do you see kind of how that pattern goes, and it just cuts it and cuts it and cuts it? So what you have to do is figure out what the actual number of half-lives that happen are, because it's not saying here. So let's look at this example, and it'll probably help you out. Okay? Carbon-14 has a half-life of approximately 37 days. Find the amount of carbon-14 left from 56 grams sample after 111 days. So what they're saying is you start with 56 grams. They want to know how much is left after 111 days. Well, here's the issue. Every 37 days, that carbon is cut in half. So you had 56. After 37 days, it's cut in half to 28. After another 37 days, it's cut in half to 14. After another 37 days, it's cut in half to 7. After another 37 days, it's cut to 3.5. Y'all seeing what I'm saying? So it just keeps getting cut in half and half. Well, we want to come up with a formula, and that's going to be kind of the formula we used up there, that'll tell us that answer instead of having to divide it in half every 37 days. So the formula, and I'm just going to copy it down so you get in that habit of it, is A, your initial amount, times 0.5, half-life, 0.5 is 1/2, to the T. Well, here are the things you need. You need A, your initial value. So how many of the sample do you start with? Well, how many did we start with? 56. And then here's the part that's a little bit different. To find your T, it's not just going to be 37 days or 111 days. T is the number of half-lives, okay? And how you get that is you take the bigger number, the number of days you're looking at, divided by the length of the half-life. So in this case, it would be 111 divided by 37. And if you do 111 divided by 37, guess what you get out? 3. So what this is saying is that in this process of going through 111 days, there's actually 3 half-lives that happen. So we now take that information and we plug it in. So we would say y is equal to, well, A was 56 times 0.5. And then T is the number 3 because you went through a full cycle of 3 half-lives. And if you plug that in and work that out, you end up getting that y is equal to 7. So that means you would have 7 grams left. Okay? So, there is that. We will see an example like that in a few minutes, okay? Let's continue on. Now, the next thing that we are going to look at is compound interest. You do not have to memorize this formula, but you need to know what it is and how things go. So this slide is going to be very important to you. Okay, so Y is going to be the amount total, so that's going to be whatever you earn. A, just like before, is your initial amount. R, just like before, is your rate. T is time and the number of years. And then we've got a new letter. What is that new letter? N. N is the number of times compounded per year. Here's what compound interest does. You get compound interest a lot when you invest money. Okay? So what that means is if you can just take money and put it in somewhere and let it sit, you make money on top of that. The more often that it is compounded is the more often you earn more money on that. Okay? So you make a lot of money doing that. It's just how long you can let it sit there. So here's the thing with N. You can be compounded a bunch of different ways, and it's all on different time frames. So I'm going to go through and give you what those time frames are. If something is compounded annually, that means it gets compounded one time in the year. If something is compounded semi-annually, 2 times in the year. If something is compounded quarterly, how many quarters are in a dollar? 4. It gets compounded 4 times in the year. If something is compounded monthly, how many months are in a year? 12. So it gets compounded 12 times. What about bi-monthly? 24, that is correct, because that means it would happen 2 times each month. Now, this next one is probably the one students struggle with the most just because they don't know. So I'm curious if y'all know or not. What if I said weekly? So what you should be thinking is how many weeks are in a year? 52, that is correct. So if it is compounded weekly, it is 52. And then the last one, the one that would make you the most money, is compounded daily, 365. Okay, now let's come down here and let's work through this example together. Okay, so what it says right here, all right, is it says if the money bank is offering a 5.5% interest rate compounded weekly and I invest $100,000, how much will I have in 3 years? Okay, so what we need to do is go through and fill out all of these things. What is our initial value? How much money are we initially putting in? 100,000. Okay. Next thing, what is our rate? 5.5%. But we know we're going to need that as a decimal. So you take 5.5 divided by 100. You get out 0.055. All right. Next thing we're going to look at is the time. Well, how long are we going to look to see how much money we made? 3 years. Now, don't get confused on this. It's not half-life. Half-life is the only one where you got to figure out the number of half-lives. Okay? And then the last thing we got to figure out is how often it is being compounded. Well, looking through here, it says it was compounded how much? Weekly. So that's where we would go to this chart we just filled in and know that that is 52. All right, now, what I'm going to do next is I'm going to set up the equation. And then you're not going to see a whole lot of my work on this paper. You're going to have your calculator. You're going to have to listen to me. Okay. So what I was saying is I'm going to write this down. You're not going to see a whole lot of work on the paper. It's going to be calculator work, and I'm going to talk to you about how you should do it, and then we'll go through it and see what you get. So as we go and plug through all of this stuff, you would get y is equal to, well, your A value is 100,000. Then you have in your parentheses 1 plus, well, your rate was 0.055 divided by N, which is the number of times we compound our interest, which here it was 52. And then that whole thing is raised to an exponent. Well, up in that exponent, you should see it is N times T. So that means you need to take your N value, which was 52, and multiply it by the T value, which is 3. Now, here's the part where I'm going to go to a bunch of calculator work. And that is typically what happens in a bunch of exponential stuff is you've got to use your calculator. So I'm going to walk you through how I would solve this. The first thing I would do, I would simplify this 0.055 divided by 52. So make sure you're listening to me. So in my calculator, I go 0.055 divided by 52 and press enter. When that happens, I got out 0.0010576923. Everybody okay with that? All right. That is just 0.055 divided by 52. Well, what else is going on in that parentheses? It needs to be added to 1. So then in my calculator, I'm just going to hit +1. So it says answer +1. So I got the exact same decimal, just with a 1 out in front. Everybody good? So, thinking back to PEMDAS, this is really what I'm doing. I just simplified my parentheses. The next thing I got to work is my exponent. So on my calculator, I've got to hit the caret button. So now it says answer with a caret. Well, up there, I need to do the multiplication of 52 times 3. So in my calculator, it now says answer and then up in the exponent, 52 times 3, and I'm going to press enter. When that happens, I got out 1.179290282. Is everybody okay? So what I have just done is taken this whole thing and created it to be a number. Now to finish it off, I've just got to multiply that number by 100,000. So in my calculator, I go times 100,000 and press enter. And when that happens, I get that y is equal to 117,929.0282. Now, what this is saying is if I had this scenario presented to me where I could get something compounded weekly at a 5.5% interest rate for 3 years, if I put in $100,000, that $100,000 in 3 years would turn into $117,929.03 once I reduce that. Okay, so my answer would be exactly like I said, 117,929.03. So just by taking that money and putting it in something like that, I would make almost $18,000 just by letting the money sit there for 3 years. Okay? All right, I don't think y'all are as checked in as you need to be, but you can see some of that. All right, so here's what's going on next. I want to do this example, and then I'm going to do a half-life example with you, and then we're going to cut the notes off so that y'all can get started on the practice, okay? So let's look at this next example. It says, find the final amount of a $500 investment after 8 years at 7% interest rate compounded quarterly. So I know you don't have it down yet. You can see it. I cannot. I'm going to write the formula up top here. It would be y is equal to A times 1 plus the rate over the number of compounded, close your parentheses, to the number compounded times the time we are looking at. So we need to get some of that information. Well, the first thing is A. What is our A value? What is that initial investment? 500. Okay. Next thing is looking at your rate. What was your rate? 7%. Well, that's really 7 over 100, which ends up being 0.07. Next thing we want to look at is the number of years that we're going to let this go. How many years? 8 years. So T is equal to 8. And then the last thing is how often it is compounded. Well, here we compound it quarterly. Well, quarterly is 4. You got it. So now we have all of that information. We just need to plug it in. So you get y is equal to 500, parentheses 1 plus your rate is 0.07, divided by your n, which is 4. Your exponent is going to be n again, so 4 times the number of years or whatever you're letting this go, which is 8. So now you've just got to listen to me and remember how we're going to do this. I'm going to start by taking r divided by n, so 0.07 divided by 4. That gets me out 0.0175. I'm going to add 1 to that. Okay, so just to show you, I'll sketch it down here so you can reference this. So now I've got 500 times 1.0175 to the 4 times 8 power, right? Well, then I need to do 4 times 8. So what is 4 times 8? 32. Y'all seeing how I'm getting all this? So then if I raise that to the 32 power, I end up getting 500 times, and I'm going to write this long decimal out, just so you can reference this later. Get that. Then to finish this off, I multiply it by 500. And I get my final answer. So that is what it is, but they want to know what is the final amount. It would be 871.11 when you round it. Okay? How do y'all feel with that? Not as easy as yesterday, but overall, if you get the process down and find your key points, you can complete a lot of this with a calculator, which typically a lot of students like. Let's do one more example, okay? And I want to go back to a half-life. My question for you is, do you want to try it on your own, or do you want me to walk you through it? Walk you through it. Perfect. All right, so it says right here that the half-life of oxygen-14 is 71 seconds. How much of a 1,250 gram sample will be left after 319.5 seconds? Okay, well, here's what we need to know. First, the formula. Formula for half-life. Y is equal to A times 0.5 to the T, but T is special. Okay, so let's first figure it out. A is our initial amount. What is our initial amount? 1,250. T is special. Okay? Because remember, it is the number of seconds you look at divided by the number of seconds, in this case, for a half-life. So the big number was 319.5. Divide that by the number of seconds of the half-life, which is 71. So if you go 319.5 divided by 71, guess what you get out? Did you get 4.5? That's what I got. So that means that in this time that it takes the gram 319 seconds, you'll have gone through 4.5 half-lives. So what we've got to do to get our answer is just come down here and plug that information in. 1,250 times 0.5. Our T is going to be 4.5. And if you do that work in your calculator, I ended up getting 55.24271728, which you know we like to round to 2 decimal places. So it would be 55.24 grams left over. Okay? All right. I am not going to do the last example. If you want to look at it for you to go through and kind of do some of that, feel free to. But you've got enough of it. You've seen enough of it. I'd rather us move on to our homework practice. So I'm going to pass that out now and let you get started. Ready, set, go.